Hello again. In this video, I'm going to go over this homework problem from section 3.4. So there's two parts to this problem. So the first part, we're supposed to find an equation for the secant line that goes through these 2 points and this function here. Okay, so let me show you how to work this out. Okay, so the first thing we're going to have to do here is find the slope of the secant line that goes through these 2 points on this function. And of course, this is the formula for the slope of a secant line. So it's f of b minus f of a over b minus a. And you can let either one of these be a or b, it doesn't matter. So I'm just going to call this one a and this one b. Okay, so then we're going to get f of 16 minus f at 9 all over 16 minus 9. Okay, and then f of 16, you've got to plug 16 into this function. And when you plug a 16 into here, the square root of 16 is 4. And then 4 times 7 is 28. And then f of 9, when you plug a 9 into here, the square root of 9 is 3. So you get 3 times 7, which is 21. Okay, and then 16 minus 9 is 7. And then 28 minus 21 is also 7. So the slope of the secant line appears to be 1. Okay, now we have to find the equation of the secant line, and we can do that by just using the point-slope formula for the equation of a line. And we now know that the slope is 1. And now we just need to plug in any point on the line, x1, y1. And in this case, there's actually 2 points that we know on this line. The first one is 9, 21. And the other one we know is 16, 28. Remember, when we plug in a 9, we got 21 out, and when we plugged in 16, we got 28 out. So those are 2 ordered pairs that we know that are on the secant line. And so you could pick either one to use for x1, y1. So I'm just going to use this first one. Okay, so x1 would then be 9, and then y1 would just be 21. Okay, and then let's just clean this up a little bit. Of course, you would distribute the 1, but that doesn't really change anything. But let's go ahead and add this 21 to both sides to get y by itself. And that leaves you with x plus 12. Okay, and so that's the equation of the tangent line, the secant line that goes through these 2 points here. Okay, so now for part B, we're supposed to find the equation of the tangent line that goes through this 1 point here. Now remember, secant lines go through 2 points, and tangent lines only go through 1 point on the function. Okay, so to find the slope of the tangent line, we have to use this formula. We have to find this limit. And in this case, a is equal to 9. So we're going to get the limit as h goes to 0 of f of 9 plus h minus f of 9 all over h. Okay, and of course f of 9, you plug a 9 into here and you get 21, which we've already done. But then what's f of 9 plus h? Okay, well, remember what this function does is whatever you put into it, it takes the square root of it and then multiplies it by 7. So the thing we're plugging into this function here is 9 plus h. So it's going to take the square root of that and then multiply that by 7. Because that's what this function does to any number you put into it. Okay? And this one, like we said, is going to give you 7 times the square root of 9, which of course is just 21. So that leaves us with this, and now we have to find the limit of it as h goes to 0. Now, you can try direct substitution to evaluate this limit, but notice that when you plug a 0 in for h on the top, you get 7 times the square root of 9 minus 7 times the square root of 9, which is 0. And that basically means that as h is heading towards 0, the top is heading towards 0 as well. And then you can also see, of course, the bottom is heading towards 0 because that's just equal to h, and h is heading towards 0. So we end up with this indeterminate form of 0 over 0. So we have to change it to a different form if we want to evaluate this using direct substitution. And so the key here is when you have these square roots, the key is to multiply by the conjugate on the top here. And so let me rewrite this a little bit, and then we're going to multiply that by the conjugate. Okay, so let's write this. So we got 7 times the square root of 9 plus h. I'm going to go ahead and write this as 21. That's 3 times 7. And now we're going to multiply the top part by the conjugate. Now the conjugate of this would be, we basically have to change the sign in front of one of these two terms. Okay, I'm going to change the sign of this one to a plus. So the conjugate would look like this. Seven times the square root plus 21 instead of minus 21. That's called the conjugate of this. Now you could change the sign in front of this one and make this one a negative without changing this one, right? So this is also the conjugate of that. I don't want to use that one because this one has more minus signs in it, and it'd be more difficult. But just so you know, this is also a conjugate of this. Okay, as long as you change the sign of one of these two terms, it's called the conjugate. So what I'm going to do is change the sign of this one to a plus and multiply by that conjugate. Now, of course, when you do this, you have to multiply the top and bottom by this because you have to multiply this by 1, otherwise you change the value of it. Okay, by multiplying it by 1, you're not changing the value of the fraction. Okay, now let's go ahead and FOIL this out on the top. You have to, FOIL because you have first, outer, inner, last here. So the first would be multiplying these two together. So that's the first here and the first here. Now the order in which you multiply doesn't matter. So you can rearrange the order however you want. And I think it'd be nice if we multiplied the 7s together, just changing the order like that, and then multiplying the square roots together. Okay, so let's write it like that. All right, so that's our first. And then the outer will be this one times this one. Again, I'm going to change the order. I'm going to put the 21 and the 7 together, and then the square root in the back. Again, the order doesn't matter here when you multiply. Then notice here you get negative 21 times 7, or 7 times 21. Again, the order doesn't matter, times that same square root. So you got first here, the outer is a plus with the square root, and the inner is a minus with that same term. So those are going to cancel out. And then the last will be negative 21 times positive 21. Okay, and let's see what that is. You get 21 times 4, let's see, that's 420. So that's going to be 441. Okay, so 21 times 21 is 421. Okay, and of course that's a minus here. You have a minus times a plus. All right, all of this is divided by h times this piece here. Okay, so to sort of finish this off now, these of course cancel out, right? Because they're opposite in sign. And here we get 49. 7 times 7 is 49, but then the square root times the square root leaves you with 9 plus h. Okay, minus the 421 all over this on the bottom. Okay, now you have to distribute this 49. So 49 times 9 would be 441. So that makes me think I may have messed up here. Let's check this. This should be 441 as well, I believe. So you get 21 on top and 420 on the bottom. So it's 441, right? Not 421, sorry. Okay, so that should be 441. Okay, so 49 times 9, that gives you 441. And then 49 times h minus 441. So you should look for these to cancel. This number over here, this f evaluated at 9, gave us this 21. And then when we multiplied it, these two 21s together, that's where the 441 came from. Whatever number you end up with here needs to cancel out with this number here. Okay, so that's how I knew there was a problem. These had to cancel out. Okay, so they do cancel out, and then on the bottom you're just left with this. And now notice that this h and this h are going to cancel out as well. So right now, if you were to use direct substitution to evaluate this limit, you would get 0 over 0, right, which is indeterminate. But since these h's cancel out, once you cancel those out, then when you try direct substitution to evaluate this limit, you actually get 49 on top. And this is heading towards 0. So that means this is getting closer to the square root of 9. The square root of 9 happens to be 3. So that means this is getting closer to 21 plus 21. So as h is heading towards 0, the entire bottom here is getting closer to 21 plus 21, right, which is 42. Okay, so overall, as h is heading towards 0, this is getting closer to 49 divided by, again, this is heading towards 0, so the square root of 9 is 3 times 7 is 21 plus 21, so it's getting closer to 49 over 42. And by the way, this will reduce because they both have a 7 in them. Just factor them. 7 times 7 over 7 times 6, the 7's cancel out, and so you just get 7/6. Okay, so that's the slope of the tangent line that goes through this particular point. And now we just need to find the equation of the tangent line. So I'm just going to erase some of this. Again, we're just going to use the point slope formula to do that. Okay. Okay, so we know the slope is 7 over 6, right? That's the slope of the tangent line. So let's just plug that in for m. Now we just need one point on the line. The only point we know on this line is that we know the x value is 9. And the y value is you plug a 9 into here, and again you get square root of 9 is 3, and 3 times 7 is 21. So it goes through this point 9, 21, and so that's your x1, y1. Okay, so x1 is 9, and y1 is 21. Okay, and now to finish this off, let's just distribute the 7 over 6 to the x and the 9. And when you multiply those together, you get 63 over 6. And then let's just add 21 to both sides to get y by itself. Of course, when you add 21 to this side, you're going to have to get a common denominator. So let's write that. Let's multiply this by 6 over 6. And so we get 126 over 6. So let me write it like that. So notice 126 over 6 is equal to 21, right? So I'm really adding 21 to both sides. I'm writing it this way because I need a common denominator of 6. So now you can add those tops together, and you get 126 minus 63, which is 63, all over 6. Okay, and then you got the 7/6 x added to that, and then over here you just have y. Okay, so that is the equation of the tangent line that goes through this point here. Okay, so I hope you found this video helpful. Thank you for watching.